Welcome to Regent House Geography podcast on Spearman Rank statistical analysis. Spearman Rank statistical analysis is looking at the relationship or significance between two variables. The equation requires a number of ingredients, RS value, which means Spearman Rank correlation coefficient. Sigma d squared means the sum of d squared being the square of the differences in our ranking system, and n is our number of variables. And for a Spearman rank to work, we need at least 10 of these variables. Now, in our studies and our fieldwork study for AS level, we looked at a river. The two variables we are going to look at today are the distance from the source and the width of the channel. The first thing that we need for a Spearman rank analysis is a null hypothesis. Here we have one on the board. The null hypothesis is a nonsense hypothesis. We have said that there is no statistical significance between change in width of channel as we move downstream further from the source. It is our job during this analysis to either accept or reject this null hypothesis. The first thing we have to do is start to find out some of these ingredients. First thing we need is to find out the sum of d squared. On the board we can see a table that's been set out with our distance downstream, or different sites, 1 to 10. We will fill in the ranking for it. We've got our second variable, which is our width. We have our rank for our width, the difference between the ranks, and then the square of the differences to eliminate any minus figures. When we rank our variables, we have to do it in the same way. There are two different ways of doing this. The way I do it is giving the highest rank to the smallest figure. And we do the same with the width. We can see here that the smallest value is actually at site number 2. What we need to do now is find the difference between our two ranked variables. So 10 minus 9 equals 1. 9 minus 10 minus 1. And the rest of the variables, 7 minus 7, 6 minus 6 will be 0. Now we square the differences. And to find the sum of d squared, we simply add up this column. D squared equals 2. Now we want to work out the RS value, the Spearman rank correlation coefficient. We've got all the variables that we require now, so we can fill them all into the equation. RS equals 1 minus the sum of 6 times d squared divided by n cubed minus n. So d squared we worked out was 2. Our n is our number of variables, which was 10, so it's 10 cubed minus 3 is 10, which equals 1 minus 12 divided by 990. And if we add that up and work it out on our calculator, we end up with an RS value of 0.99. Spearman Rank correlation coefficient of 0.99. What does that mean? Well, at this point we're looking at a correlation between two variables. If we have a straight line with 0 in the middle, where there's no correlation between our figures at all, on the right hand side we have +1, which shows us a perfect positive correlation, and on this side a perfect negative correlation, -1. This type of correlation here would look something like that. And a perfect negative correlation would look something like that. Now our RS value is 0.99. Which falls very, very close to 1. So we have a very, very strong correlation between the results for our width changing as we go further downstream. Now what we have to do is find the significance of our results, okay, and we need some ingredients for that. We need a significance chart, which will always be provided in our exam booklet. We need a Spearman Rank correlation coefficient, our RS value, which we have worked out as 0.99. On our significance chart, they also ask for a degrees of freedom number. It's n minus 2. In our case, we have 10 variables for n. Minus 2 equals 8. We are now ready to plot these points on our significance chart. So here we have a typical standard significance chart. You can see we have our degrees of freedom along the bottom. We have our Spearman Rank correlation coefficient up the side. We can also see these three red lines. Okay, these red lines show the likelihood that this did not happen by chance. Here we have the 0.1% showing us that it is 0.1% of the time it happened by chance, 1% it happened by chance, and 5% it happened by chance. Statistically, if any of our figures plotted fall below the 5% line, there is no statistical significance. So everything that we plot must be above the 5% line. So if we take our two variables, our degrees of freedom, which is 8, and our RS value, which is 0.99, we see that we're plotted quite high on this line here. We're up about the 0.1% chance line. Okay, so that means that 99.9 times out of 100, our results will always show that width will increase as we move downstream, and that only 0.1% of the time it will happen by chance. Now this is where it comes in very important. Now what we have to do is actually write this up into our booklet, into our answers form, and we need to put a paragraph together. So at the end of this we need to fill in our Spearman Rank significance paragraph. What have we found? What we have found is that the RS value of 0.99 shows a very strong positive correlation. At 8 degrees of freedom, the 0.99 RS value falls on or above the 99.9% line, or the 0.1% chance line. This means that 99.9% of the time width will increase with distance downstream. This statistical significance allows us to reject our null hypothesis. On the next slide you will see an example of an answer that you would fill in on the sheet. All of the stuff that we have done here today must go into that little box. I hope this helps. If you have any trouble, give me a shout.